this video, I'll look at a form of lossless data compression coding, which is basically pictorial or visual approach to lossless data compression, which is basically geometric coding, which affords a very high order of compression. Now, this itself is of two types. One is a literal geometric coding. The other one is a figurative approach. The figurative approach is basically weight redistribution coding. Here, if 2 power L dash is mapped to 2 power L losslessly, L dash nearly equal to L cube, close to L cube, L square to L cube, somewhere between that it offers very close to L cube. In this literal geometry coding can be of two types. One is normal or regular one, and the other one is a more optimal one. Here I shall just look at this optimal approach to literal geometric coding, and possible also mention normal coding, how it is done. It is much simpler and an idea that occurs much more readily. Now, in this optimal approach, it is based on the fact that the perimeter of a regular figure being constant, regular symmetric closed figure, geometric figure, say P being constant, the area enclosed by it is minimum for a three-sided figure, which is a triangle. If P is a so the number of sides n, which is basically an equilateral triangle of same sides. So the area will, this length of each side will be P by 3. As the number of sides increases, P being the same, as the number of sides increases, the area is enclosed by a square of the same perimeter will be more than that of the triangle. Same for a five-sided figure also. The area is enclosed by the five-sided figure will be more than that as enclosed by the square, perimeter being the same for both and the area is enclosed by a six-sided figure will be more than that enclosed by a, as the number of sides increases and the figure becomes closer and closer to a circle, the area is enclosed by the circle will be the maximum. So the idea here is very simple. Now if you can easily calculate the area of an n-sided regular figure by, for a given fixed perimeter, area, as you can see, area turns out to be some area equal, if P is the perimeter, P square by 4 n tan pi by n. So in this form of geometric coding, what happens is we have to code a value m equal to say 2 power L dash in a value s equal to 2 power L, where L dash is much larger than L. Losslessly code this value. So we assume a certain convenient base. So what happens is, rather than assume 2, I will assume that s is coded in a base b. Rather than 2, even though I have mentioned it as 2 here, I will assume a base b here, convenient base b, and code it as b power L. Okay, so the L digits of base B is what is the size of the chord. So length of the chord will actually be log B to the base 2 times L. This will be the length of the chord. Now what happens is, since the base is B, the value of 0 of course will be ignored as not representing any. Here what we do is, each value of the chord for S is, when broken down in base B, is associated with an n-sided figure, assuming a reasonable perimeter. So if all of them turns out to be 0, you will have to decrease the perimeter to a significantly large value. So the value of 1 will be associated with a triangle which is a 3-sided figure, and the value of B minus 1 will be associated with B plus 1 sided figure. There are again value of 1 for the preceding digit, that is for the smallest digit. For the preceding digit of S, the value of 1 will be associated with B plus 2 sided figure, and the value of B minus 1 for that digit, for its preceding digit, will be associated with the value 2B. Again, for the leading third digit, the value of 1 will be associated with 2B plus 1, and the value of B minus 1 will be associated with 3B minus 1, like that. So in all there will be B minus 1, the maximum number of sides will vary from 3 to B minus 1 into B minus 1 into L plus 3 plus 2. So this is how the coding is done. So now what happens with the leftmost digit will represent, the leftmost digit of the chord will represent the maximum value m itself, and that is the area is enclosed by a maximum value of n-sided figure, as the area is enclosed by the n-sided figure where n is the maximum value, and the next smaller digit will be the area of the n minus 1 sided figure, as enclosed by an n minus 1 sided figure, the perimeter being the constant, like that. So like that, for decreasing values of n, it is coded. The difference in the areas between any two figures is what is actually the area that is coded as an corresponding n-sided figure for the next digit. The difference in areas between these two, as enclosed by these two figures, n and n minus 1 sided I or I minus d or d plus d and d minus 1 sided figure. D is the digit for which is what is coded here, and so on. The value of 0 implies that it is smaller than the smallest area as enclosed for m. This value as enclosed by m might be smaller. If many of them turn out to be zeros, because m is the value you have chosen for, even though m is large, all of them are leading zeros, then all of this will turn out to be zeros, which can be clipped and noted how many zeros are there. But that will never occur, because the larger numbers have a much larger probability of occurring. So this is your optimal approach to geometric coding. In the normal approach, what happens is, we could take any side figure, 3-sided. Here we do not fix the perimeter. We associate the perimeter of a regular figure with the value of s, but allow for variation in the perimeter and code the difference in the area between different values of the perimeter corresponding reasonably varying values of the perimeter as a value in s. So the area is represented by that. This is your normal or a simple or regular one, which occurs immediately. This again offers, since the area is if the perimeter is P, area will be close to P square. This will afford half the length compression, fairly losslessly, fairly very good, close to half the length compression. So here again I can increase the number of sides in the here again you are allowed to assume a reasonable variation in the perimeter and quote the side only as expressed by as the value of the code, and the area, corresponding area, is enclosed by that figure as the value for the information. So it will come close to half only as the number of sides increases. So basically this is your geometry coding. It should afford a very high order of lossless data compression.